Let's look at some applications for linear functions. We recall that a linear function means I have a constant rate of change. It can be increasing or decreasing, but it's a constant change as we move forward. This particular situation where I have a disc jockey who has a certain number of albums and is buying a certain number of albums every week is a good candidate for a linear model because we have a starting point and we have a constant rate of change. So the starting point is my 450 albums, and we are adding to that 3 every week. So I would just multiply the number of weeks, and that would tell me how many I've added. So formally, I would have f of x is equal to 450 plus 3x, where x is the number of weeks. So the y-intercept is my initial number at time 0, and the slope is my rate of change. So if they want me to calculate how many albums she would have in 12 weeks, well, they're telling me the x value, we'd plug it in and work it out and find that she would have 486 albums. Take a look at another one. We have a school population of 1,001 in 2004, but it's growing, and by 2008, it had grown to 1,697. We're going to assume linear growth in this problem. Okay, so how would we find the model? Well, we know what the initial value was. The time 0, or the y-intercept value, is 1,001. What we have to calculate is the rate of change. Remember, the rate of change is the ratio of the change in the y values, in this case population, over the change in the x values, in this case years. So we would take the difference, 1697 minus 1001, and 2008 minus 2004, and we come up with a positive 174. That makes sense to us because it is an increasing population. So that's my rate of change, or my slope. So my formula is f of x is equal to the 174x plus the 1001. Now I do want to note that x is, in this case, not the actual year, but the number of years since 2004. Okay, so it's the amount of years that elapsed since we started our model. So if we want to determine when the population would be 2,915, this is my model. They didn't give me the x, I'm finding the x, so they've given me the population, or the f of x. So I plug that in, and then I solve a linear equation and determine that x is 11. Well, there is no year 11, that wouldn't make sense. So we go back to, what does x stand for? It stands for the number of years since 2004. So 11 years after 2004, add 11, you come up with the year 2015. Let's take a look at another. This one's a little bit different because this time we're involving depreciation, which means we're going to be decreasing in value. So our truck starts at $32,000 and depreciates to $24,500 in just 3 years. We want to assume that depreciation is linear and then find a model and answer some questions. So again, one of the first things we have to determine is, what is the rate of change? Well, my new amount was $24,500 minus my original amount, divided by the change in time, 3 years, leads me to a negative 2,500. Okay, now if you had mixed up those amounts, you would just have to really reason out to yourself, wait a minute, this is depreciating or decreasing, so I have to use a negative rate of change here. So our model is going to be f of x is equal to my initial 32,000, or my y-intercept, minus 2,500x. It's the exact same thing if you would put negative 2,500x plus 32,000. It's just whatever you prefer. Okay, so the second part was to determine the value after 5 years. So this is our formula, and they've given us the time, so I just plug it in, and I calculate out 19,500. If they want to know when the truck will be worth 5,000, now they've not given me the x for my formula, they've given me the answer to my formula. So I set the equation equal to 5,000 and do the algebra and come up with x is equal to 10.8. Well, that's going to mean near the end of the 10th year, almost at 11 years, it'll be worth just $5,000. Now, if I were to take this function, 32,000 minus 2,500x, and graph it, I would see this. Okay, so here's my y-intercept, right? There's the 32,000. So the y-intercept is the initial value at time 0 at the very beginning. And then I can see the rate of change. It's decreasing $2,500 every year that we move forward. And then I can look here at the x-intercept and say, now what would that mean? Well, at the x-intercept, my y value is 0 and the y value is the value of my truck. The X value is the years. So that tells me at almost 13 years, my truck really has 0 value, at least as far as tax is concerned. Hopefully that helps. Let me know if you have any questions.